Welcome to online learning program of MSBTE, Learning at your doorstep. I am Sangeeta Boyer, lecturer at VES Polytechnic, Chembur, Mumbai. Today we are going to discuss arithmetic instructions from Unit 2, Instruction Set and Programming. So, today's learning outcome is to describe various arithmetic instructions with suitable examples. Under this, we will see how arithmetic operations can be done in 8051 microcontroller. Instruction set of 8051 microcontroller is having 5 types of instructions: data transfer instructions, arithmetic instructions, logical instructions, Boolean variable manipulation instructions, and program branching instructions. In the previous lecture, we had learned about various data transfer instructions. Today, we will discuss arithmetic instructions: add, addc, sub, mul, div, inc, dec, daa. All these instructions fall under arithmetic category. 8051 microcontroller supports 8-bit arithmetic unsigned operations. One of the operand in arithmetic instruction is accumulator. Other operand, if there, will be immediate value, direct memory, register, register indirect, except in case of MUL and div, where register B is used to hold the value of the second operand. The carry flag, auxiliary carry, and overflow flag are affected based on the result of arithmetic instructions. In 8051 microcontroller, there are 24 different instructions under the arithmetic group. So we will discuss one by one. Arithmetic instruction add. Add instruction is used to add two operands. The destination operand is always in register A, while the source operand can be a register, immediate data, or in memory. Carry flag, auxiliary carry, and overflow flag are affected based on the result of operation. Add A, Rn. This instruction adds the contents of a register Rn to accumulator and store the result in accumulator. Rn is one of the register from R0 to R7 from selected register bank. Example, add A, R3. If accumulator contains 33H and register R3 contains 24H, then 33 will be added to 24 and result 57 will be stored in accumulator. Add A, direct. This instruction adds the contents of direct internal memory location given in the instruction to accumulator and store the result in accumulator. Example, add A, 50H. If accumulator contains 33H and memory location 50H contains 24H, then 33 will be added to 24 and result 57 will be stored in accumulator. Add A, @ri. This instruction adds the content of internal memory location pointed by ri to accumulator and store the result in accumulator. Ri indicates register R0 or R1. Only registers R0 and R1 is allowed in this mode. Example, add A, @R1. If accumulator contains 33H and register R1 contains 40H, then 33 will be added to content of memory location 40H, that is 24H, and result 57 will be stored in accumulator. Add A, hash data. In this instruction, add immediate 8-bit data given in the instruction to accumulator and store the result in accumulator. Example, add A, hash 56. If accumulator contains 33H and immediate data given is 56H, then 33 will be added to 56 and result 89 will be stored in accumulator. Add C instruction. Add C instruction is used to add two operands considering carry. Add C A, Rn. This instruction is used to add content of a register Rn and content of carry flag to accumulator and store the result in accumulator. For example, add C A, R3. If accumulator contains 33H and carry flag is 1 and register R3 contains 24H, then 33, 1 and 24 will be added and result 58 will be stored in accumulator. Add C A, direct. This instruction adds the content of direct internal memory location given in the instruction and the content of carry flag to accumulator and store the result in accumulator. Add C A, @RI. This instruction adds the content of internal memory location pointed by RI and content of carry flag to accumulator and store the result in accumulator. Add C A, hash data. This instruction adds immediate 8-bit data given in the instruction and the content of carry flag to accumulator and store the result in accumulator. For example, if immediate data given is 56H and carry is 1 and accumulator containing 33. So 33 will be added to 56 considering carry flag and the result 8A will be stored in accumulator. Arithmetic instruction sub. The sub instruction subtracts the byte variable indicated and the contents of the carry flag together from the accumulator and puts the result back in the accumulator. The carry flag serves as a borrow required during subtraction operation when a greater value is subtracted from lesser value. Sub A, Rn. Subtract the content of a register Rn and content of carry flag from accumulator and store the result in accumulator. For example, sub A, R3. If accumulator contains 33H, carry flag contains 0 and register R3 contains 55H, then 55 will be subtracted from 33 and the result CE will be stored in accumulator. During subtraction, 55 is greater than 33, hence carry flag served as borrow and it becomes 1. Sub A, direct. This instruction subtracts the content of direct internal memory location given in the instruction and content of carry flag from accumulator and store the result in accumulator. Sub A, @RI. This instruction subtracts the content of internal memory location pointed by RI and content of carry flag from accumulator and store the result in accumulator. Sub A, hash data. This instruction subtracts immediate 8-bit data given in the instruction and the content of carry flag from accumulator and store the result in accumulator. Now, before we proceed further, please attempt MCQs from set 1 which is given to you as assessment sheet. Proceeding further, we have increment instruction. INCA. This instruction increments the content of accumulator by 1. Example, if accumulator contains 23H, then after execution of this instruction, accumulator will contain 24H. INC Rn. This instruction increments the content of register Rn by 1. If the register R5 contains data EAH, then after execution of this instruction, it will contain EBH. INC direct. This instruction increments the content of direct internal memory location given in the instruction by 1. INC @RI. This instruction increments the content of internal memory location pointed by register RI. INC DPTR. This instruction is used to increment the content of data pointer by 1. Suppose DPTR containing value 330E. So after the execution of this instruction, data pointer will contain 330F. Decrement instruction DEC A. This instruction decrements the content of accumulator by 1. If accumulator contains 23H, then after execution of this instruction, it will contain 22H. BEC RN. This instruction decrements the content of register RN by 1. If register R5 contains data EAH, then after execution of this instruction, it will contain E9H. DEC direct. This instruction decrements the content of direct internal memory location given in the instruction by 1. DEC @RI. This instruction decrements the content of internal memory location pointed by RI by 1. Mul AB. Mul AB instruction multiplies the unsigned 8-bit integer in accumulator A and register B. After multiplication, lower byte of the result will be stored in accumulator and higher byte will be stored in B register. After execution, the carry flag is cleared. If accumulator contains 04 and register B contains 02, then result 08 will be stored in accumulator. DIV AB. This instruction divides the unsigned 8-bit integer in the accumulator A by unsigned 8-bit integer in register B. Quotient will be stored in accumulator and remainder will be stored in B register. After execution, the carry and overflow flag is cleared. If accumulator contains 09 and register B contains 02, then quotient 04 will be stored in accumulator and remainder 01 will be stored in B register. DAA instruction. When two BCD numbers are added, if the result is non-BCD, then to get the result in BCD, DAA instruction is executed after adding two BCD numbers and store the result in accumulator. For example, add A, R1 DAA. Consider case 1. If accumulator contains 23 and register R1 contains 55, then result is 78, which is valid BCD. So, result will not be altered after DAA instruction. Consider case 2. If accumulator contains 53 and register R1 contains 58, then result of addition is AB, which is invalid BCD. So to make it valid, 6 is added to lower and higher nibble. So after execution of DAA instruction, we get valid BCD number 11, which will be stored in accumulator and carry flag will becomes 1. Now please take MCQs from set 2 which are given in your assessment sheet. Let us have quickly recap of important points. In arithmetic instruction, we have discussed add. Add instruction adds a byte value to the accumulator and store the result back in accumulator. Add C. This instruction adds a byte value and the value of carry flag to accumulator and the result of addition is stored back in accumulator. Sub. Sub instruction subtract the specified byte variable and the carry flag from accumulator. INC. This instruction increments the operand by 1. DEC. This instruction decrements the specified operand by 1. Mul multiplies the unsigned 8-bit integer in accumulator and in register B. GIV. This instruction divides the unsigned 8-bit integer in the accumulator by 8-bit integer in register B. DAA. This instruction allows addition of numbers represented in 8-bit packed BCD code. Thank you.